Hello and welcome to this video on section 7.6. This is a video on indirect proof. And so what I'm going to do is I'm going to basically just work on three proofs, two that I have here and then one from MindTap. And as I go along, I'll explain my thinking process and what I'm doing. Indirect proof is very similar to a conditional proof. So it is important that you understand section 7.5 on the conditional proof because the structure is basically the same. Okay, so let's start with the idea of a contradiction, because the idea of a contradiction is central to how an indirect proof works. A contradiction is the worst possible thing you could ever have in logic. It's a kind of a logical monstrosity. It's something that we never want to have, and it's also true in philosophy. In philosophy, we do not want to have contradictions. So let me begin by explaining what a contradiction is. Here I have two statements. Yesterday I went to the movies, and yesterday I did not go to the movies. So notice that yesterday I went to the movies is an assertion, right? It's a statement, it's a proposition. I have it here symbolized by Y. The negation, or the opposite of that statement, is yesterday I did not go to the movies, right? So the question is, how can I get a contradiction here? Basically, what I have to do in order to get a contradiction here is just conjoin those two statements. Yesterday I went to the movies, and yesterday I did not go to the movies. If we have that conjunction, here it is, let me make that a little bit bigger there. If we have that kind of conjunction, then we have a contradiction. And that's because it makes absolutely no sense whatsoever that yesterday I went to the movies and yesterday I did not go to the movies, right? That is just the most absurd thing anybody can think of, or that anyone can say. And that is a contradiction. So notice that if we want to represent that in a symbolized way, it has to be a conjunction. Here's the word and, right? And here it is highlighted in a symbolized way, which is Y and not Y, right? Y and tilde Y. So it only works with a conjunction. It's basically the statement. A contradiction only works with a conjunction. It's basically a statement conjoined to its negation. It does not work with a disjunction. So if I say yesterday I went to the movies or yesterday I did not go to the movies, that can actually logically make sense, right? But remember, for a disjunction, we only need one of them to be true. And so if it is true that I went to the movies yesterday, then Y or not Y would be okay logically, but not the conjunction. The conjunction will lead us to a contradiction. One other thing that I want to point out philosophically is that a contradiction is not the same thing as a paradox. A paradox in philosophy is okay, and in fact, paradoxes are very interesting in philosophy. One example of a paradox is change is the only constant. So why is that not a contradiction, and why is that okay? Okay, well, notice first of all that with the statement change is the only constant, we don't have a contradiction because we don't have two statements, right? We only have one statement. We don't have a statement and it's conjoined to its negation, right? And saying change is the only constant might sound a little weird, but it actually makes sense, right? All I'm saying is basically that things are always changing, right? Things are constantly changing, which sounds weird because the idea of change is kind of opposed to the idea of something being constant, right? But we know what we mean, right? We can meaningfully say change is the only constant. And as a matter of fact, there was an ancient philosopher by the name of Heraclitus who believed and taught that change is always going on around us, right? So paradoxes are okay and they're fine. It's contradictions that we want to avoid. And so it's this idea of a contradiction that we're going to need to make use of here in indirect proof. So let's go ahead and get started with the proof. So here's the first one I'm going to do. I'm going to do two here and then another one from MindTap. Here's the first one I'm going to do with the first two premises here, if A then B, and then the second premise, if A then not B. Notice that what I'm trying to prove is not A, and I have that over to the top right over there. Let me move this down here so that this is not confusing. Let me move the second one a bit down here. Okay, so as I said earlier, this is going to work pretty much the same way as a conditional proof. And so what I have to do is I have to start off with an assumption over to the far right. Remember, with a conditional proof, I hit the tab button to move everything over to the right. That's the same thing. We're doing the same thing here, except our assumption here is going to be different. There's a different logical strategy here to the assumption. Okay, well, notice that I'm trying to prove not A, right? Okay, well, what if I assume A, and by assuming A, I logically show that A leads to a contradiction. If I assume A and I logically show that A leads to a contradiction, well, then I can show that that's absurd, right? And if A leads to a contradiction, then the opposite of A, which is not A, has to follow. So that's basically the structure here, is to assume A, and then my justification here is very similar to the conditional proof, except it's AIP, which is assumption for indirect proof. And so again, I'm just basically assuming that A is true. If A leads me to a contradiction, then not A will follow. Okay? All right. Well, so we start with A as being assumed. We now have to derive further premises. So if A is true, we notice that we can get a lot out of that, right? Because notice that we can use modus ponens to get, we can actually get B and we can get not B, right, by modus ponens. So let's start with B. B follows with 1 and 3 modus ponens, right? So notice that I'm just using the rules as I normally would. I'm not doing anything different in terms of the rules, and I am using all of the rules here, by the way. So remember, these are the rules. We have a total of 18, and we can use all of them. Here are the rules of replacement, and here are the rules of implication. Okay, so I derive B by using 1 and 3 modus ponens. Can I get something else? Well, again, yeah, modus ponens here is going to also give me not B, right? Notice that 2 and 3 via modus ponens will give me not B, right? Okay, so now do I have the contradiction yet? Well, notice that I have B in line 4, and notice that I have not B in line 5. So can I conjoin them? Is there a rule that allows me to conjoin them? Yes, there is, right? Conjunction will allow me to assert B and not B, right? I'm going to have to go get the dot, the conjunction symbol here, copy and paste. Conjunction allows me to put B and not B together, and that is justified by lines 4 and 5 conjunction, right? Remember, conjunction is abbreviated CO and J. Okay, well, there's our contradiction, right? This should be a tilde B. B and not B is a blatant contradiction that we just talked about, and so that's it. Basically, what we've done is we've shown that if we assume A, that gives us a contradiction, B and not B. If that leads us to a contradiction, then the opposite of A has to follow, because if anything can follow from a contradiction, it's so absurd. But if we show that A, the assumption of A leads us to a contradiction, then not A, its opposite has to follow. And so then this is justified in a very similar way that the conditional proof was justified. We would have to cite lines 3 and 6, except instead of CP, we now have it justified as IP for indirect proof. Okay, so that's it. That's how indirect proofs work. It makes use of this idea of contradiction. Let's do another one, which is a little bit longer. So here, notice that I want to prove. Let me get rid of these spell check um, uh, symbols here. So just take a little while. Okay, let me move on then. Again, remember what we're doing here. It's the same strategy. We're trying to prove Q. And so in order to prove Q, we should assume the opposite of Q, right? In this case, we have to assume not Q, because if we can show that not Q leads us to a contradiction, then we're basically employing the same strategy, right? We're showing that not Q leads us to a contradiction, and so Q has to follow, right? Same exact strategy. Okay, so if we assume not Q, and that's our assumption for indirect proof, what else can we get out of this? Okay, well, we do need to employ a general strategy here. We have to think strategically from the beginning. We assume not Q. Can we get Q, and can that be our contradiction? Absolutely. The goal here is just to get a contradiction. It doesn't really matter whether that uses the Q or not. As long as we get a contradiction, then we can we can conclude that Q follows. Okay, well, how do we get a contradiction? Well, then notice that we have to get Q, right? Because then we can conjoin Q and not Q. So the question is, how do we get Q? Notice that our antecedent here is not M and not M and N, where we have the tilde outside of the parentheses, right? But also notice that this is a version of we could use a version of De Morgan's here, right? Remember De Morgan's. Let's project De Morgan's here. De Morgan's we have right here. Let me make that larger. We have not P and Q is equivalent to not P or not Q, right? Well, notice that that's basically what we have here in the antecedent. So why don't we get not M or not N, and then make it equivalent by using De Morgan's, and then we can get the Q, right? So our immediate task here is to get the not M or not N. We already have the not N over here. Notice that it's already there. So why don't we pull that out of there? Remember that we could do that with commutativity. We have to use commutativity first, right? So we could apply commutativity to line 2, and that's justified by 2 COM, right? The commutativity rule, which is right here. That allows us to get the not N now, because now we could use simplification, right, and get the not N out of there. And so that's justified by 4 simplification, right? We've simplified 4 to get that not N out of there. Okay, so notice that now we need the not M, right? Remember, we're trying to get not M or not N, but we don't have the not M yet. We have the not N, right? So how do we get the not M? Actually, we could get the not N or not M by adding it to line 5, right? So in line 6, I could just write not N or not M. And all I've done is I've added it to line 5. Well, notice that, and so that's justified by addition, right? Notice that I'm almost there. I got not N or not M. Remember, I want not M or not N. Well, how do we get that? Well, we use commutativity again, right? Except this time we put the not M in the first position, we put the not N in the second position, right? And so that's justified by commutativity on line 6, right? COM again. Okay, notice that I now have what I want in terms of of my strategy of using De Morgan's. So in line 8, we do have to get this variation here. Remember, the antecedent is what we wanted to get, and so that is justified by using applying De Morgan to line 7, right? De Morgan's to line 7, and that is exactly what I wanted, right? All I did is I found the equivalence to not M or not N, which is tilde, M and N inside the parentheses, right? By the use of De Morgan's. Okay, remember that my strategy here was to use modus ponens, and so if you look at lines 1 and lines 8, we can apply modus ponens. Remember, modus ponens works if P then Q, P therefore Q. Our if P is right there, and our Q is our Q there, capital letter Q. If P then Q, P, this is our P here, therefore Q. Okay, so Q follows, and it follows by lines 1 and 8, modus ponens. Remember, what I wanted to do was get the contradiction, but I do have to conjoin Q and not Q to get that contradiction, right? So we have to apply the conjunction rule, Q and not Q, and that is justified by lines 3 and 9 conjunction, right? Okay, that is our contradiction. Remember, this is a monstrosity, and we got to that contradiction by assuming that not Q was true. So our line 11 here is Q. Q follows because not Q has led us to a contradiction, and our justification, remember, is lines, and we could put justification anywhere over here. It is lines 3 through 10. And that was justified by our use of indirect proof, right? So IP lines 3 through 10, and that's it. That gets us our conclusion. Okay, so the last thing I'm going to do is I'm going to do this in MindTap. And so again, the strategy works the same way here, except remember here we're doing it in a different format, that's all. So notice that here we're trying to prove not S. We only have one premise, which is S or if S or T, then not S. So again, let's use the same strategy. If we're trying to prove not S, why don't we assume S and show that S leads us to a contradiction, right? So our first step here is to assume S, and that will be AIP, assumption for indirect proof, right? We have to show that S leads us to a contradiction. Okay, well, now that we have S, we have to get other stuff, right? Well, first of all, we have to try to get not S, right? Remember, it doesn't matter how we get the contradiction as long as we get the contradiction, right? So if we have S, why don't we try to get the not S out of there, and then we'll have our contradiction. S and not S, right? That will get us our contradiction. Okay, well, how do I get it? How do I get that not S out of there? Well, notice that we could eventually employ modus ponens. If we can get S or T, then we have basically our P in modus ponens. Remember, modus ponens, if P then Q, P therefore Q. This will be our P, and our not S will be our Q. Okay, well, how do we get S or T? Well, notice that we could just add S, we could just add the T to the second premise by the addition rule. Remember that the addition anything, right? So we could add the T, and that's justified by addition on line 2, right? Our second premise now. Okay, so we have our S or T. We got it by adding it to line 2. Now we could employ our modus ponens, right? Modus ponens, if P then Q. Here is our P. Here's our Q. P, here's our P again, therefore Q. So line 4 basically means that not S follows by lines 1 and 3 modus ponens, right? That's justified by MP. Okay, Well, notice that we now have basically our contradiction. We have as, and we also have not as. So let's go ahead and conjoin them, and that's easy. We just click on s there, click on the dot, and click on tilde and s. That is our contradiction. How did we get the contradiction? Well, all we did was we conjoined lines 2 and 4, right? 2 and 4 conjunction gave us that contradiction. Okay, are we done yet? Almost done. We have shown that by assuming S, we have gotten a contradiction, which is S and not S. And remember, the strategy here was to show that S leads us to a contradiction so that we can conclude the negation of S. Well, the negation of S is exactly what we want to prove, right? And so our final step here is to write not S, and our justification here, remember, is basically lines 2 through 5, indirect proof. You do have to click on 2 and 5, and then on IP for indirect proof. There's no way to write 2 slash 5. I'm sorry, 2 through 5. You know, the kind of the not symbol in mathematics. You just have to click basically on 2 and 5, and that basically represents that you've used the indirect proof for lines 2 through 5. And so that gives us what we wanted to prove, right? Notice that everything is now shifted back, or line 6 at least, which is our conclusion, which is what we wanted to prove, is shifted back over to the left, right? Remember that this is called discharging the proof. We've discharged 2 through 5. That's the same as what we did in the conditional proof. That step is basically the same, the discharging portion. Okay, so not S is what we wanted to prove. We followed this strategy of showing that that S leads us to a contradiction, and so we can conclude not S since S leads us to a contradiction. So if we click submit here, that should show us that this is correct, and there it is, and so we've done that the right way. Indirect proof has a name, a Latin name. It's called reductio ad absurdum, and that literally means reduced to absurdity. So that might help you to remember that what we're doing here is we're reducing something to absurdity, and that's basically what we assume, right? In this case, we take the S, and then we can conclude the opposite, which is not S. So in a way, in some sense, we've reduced S to an absurdity, and that's the Latin name, reductio ad absurdum. Hopefully that'll help you remember it.